we've got a very interesting integral right here. So we're going to integrate this, but here is the hint that you're going to be using. So we're going to use the substitution, u equals the sixth root of x. So I'm going to go ahead and just rewrite it this way for you. So if you let u equals, let's say x to the 1/6, because that's sixth root of x, and we want to find the derivative of u. So before we do that, we're going to, let's raise both sides to the power of 6. So that way you can simplify the fraction. So if I raise both sides to the power of 6, then you have u to the 6 is equal to x. And now I can take the derivative on both sides respect to x. On the left-hand side, my derivative of u to the 6 will be 6u to the 5th du is equal to dx. So here you have an expression for dx, and we're also going to use this substitution for x to the power of 1/6. Now here's what we're going to do. We're going to come back to our integral and rewrite this. So we have the integral. Now before I do any sort of factoring, I'm going to rewrite the exponent. So this is 1 over a square root of x that can be written as x to the power of 1/2 minus and cube root of x that can be written as x to the power of 1/3. Now you can use some algebraic technique to simplify this or rewrite this a little bit further. So what we're going to do, we're going to take out the greatest common factor from the denominator. In other words, the GCF. So I will take out x to the 1/3, and then I'll refactor the inside. So if I take out x to the 1/3, then in here I'm going to get x to the 1/6 minus 1. So that's how the denominator refactors. Again, if you're not sure how we got to that, you can think of it this way. You can redistribute these and say, okay, x to the 1/3 times x to the 1/6, but what will that give us? So here we have to get x to the power of 1/2. What will give us that? So what you can do, you can use the laws of exponents. You add these up. So we know 1/3 plus 1/6. When you common denominator, times this by 2/2. So that's going to give you 3/6, which is 1/2. Check. So it works. So we get the first term. And then, of course, the second term, x to the 1/3 times -1. That will be x to the 1/3. All right. So our factoring is good. We double checked everything. Now, here's when you're going to replace everything in terms of this new variable, u. But before that, I'm going to have to rewrite this term one more time because it doesn't appear to be x to the 6th. So what you can do, you can rewrite it like this. So I want x to the 6th to appear there. So I'm just going to force it to look like this. If I do x to the 1/6 squared, then this is really x to the 1/3. So hopefully you can see that by laws of exponents. And that's what I'm going to do. I'm going to rewrite this guy as x to the 1/6 squared, because that's really x to the 1/3. I didn't change the question. I just rewrite them in a way so we can use the substitution we were given as a hint. So that's where I'm going to plug in right here. So this would become the following. We will have the integral of 1 over x to the 1/6 squared times x to the 1/6 minus 1 dx. And now we're ready to make the substitutions. So x to the 1/6 is replaced with u, as we're saying it right here. And then dx, it's going to be replaced with that. So let's do that. So this is equal to the integral of dx is replaced with 6u to the 5th du, and x to the 1/6, that's going to be u. So it's squared times x to the 1/6, that's u, minus 1. There you have it, everything in terms of this new variable. Now we integrate this function. So I'm going to go ahead and simplify these terms right here, because by using laws of exponents, you can simplify that. So this is equal to 6 du, not 6 du, this will be, you subtract the exponent, so 6u to the 3rd over du over, and then u minus 1. So if you like, you can put the du right here so that it doesn't interfere with the way you're working out the problem. Now, this is an improper fraction. And since this is an improper fraction, the degree of the numerator is higher than the degree on the denominator. We will have to go through a long division. So let's go ahead and do that. I'll leave a link in the description box for you to check out how to perform long division. So let's take a look at this. So here's your, this is the divisor, this is the dividend, and this is how we're gonna set it up. U minus 1 is right here, and the numerator is right here, 6u to the third. Now let's proceed. So we're gonna put a term here. When we multiply that term with u, will give us this guy right here. So that term has to be 6u squared, because 6u squared times u would give us 6u to the third. And then you just simply take that term and multiply to -1, and that goes right here. So 6u squared minus -1, that's minus 6u squared. Now you subtract away everything you obtain. So these guys will cancel out. So negative 6u squared, that's positive 6u squared. And now you repeat. So now we need to figure out what term times u will give us 6u squared. Well, that has to be positive 6u. So 6u, now we repeat the process, 6u times u gives us what? That will put on the denominator right here. So that will be 6u squared. And then 6u times -1, that's negative 6u. And then we subtract away everything. All right, so now again, these cancels always, and then negative 6u, that's positive 6u. And now we repeat, we need a plus 6 because 6 times u will give us 6u, and then 6 times -1, that's -6. Then we subtract away everything. So this cancels, we get positive 6 as the remainder, since this would not, 6 would not go into a u minus 1. All right, so here's our way to write this. This is what we call our quotient. This is the remainder, that's the divisor. So this integral is equivalent to the integral of the quotient, that's 6u squared plus 6u plus 6 plus the remainder, which is 6 over u minus 1 du. So that's what it comes down to. And now we're ready to integrate each of these p's, since they're very easy to integrate. The first one we integrate by using the power rule. So 6u squared, that will be 6u to the third over 3. And then the second one is also power rule, 6u to the second power over 2, plus integral of 6 respect to u, that's 6u. Plus 6, the last one, you can use a U-substitution or another substitution, really. And you'll see this will be 6 times ln of absolute value of u minus 1 plus c. All right, so we have successfully finished integrating. Now let's go ahead and simplify these coefficients. So 6 over 3, that's going to be 2u to the third, plus 6 over 2, that's 3u squared, plus 6u plus 6 ln of u minus 1 plus c. Now, since they all have 6, well, not all of them right now, you could factor things out. For example, you can probably factor out a 6 from here, but that's really not necessary. We can leave it in this form. But now, before we interpret this as our final answer, we need to plug in what u is. So if you go back to the original, we wanted u to be that, x to the power of 1/6. So that's where I'm going to plug in right now. So we're almost to the final answer. This is 2 times u is x to the 1/6 to the third power, plus 3 times x to the 1/6 to the second power, plus 6 times x to the 1/6, plus 6 times ln of absolute value of x to the 1/6 minus 1 plus c. Now, if you would like, you can leave it here, but I think we can do better than that. We can simplify these exponents. So the next step would be to just simplify them. So this is 2x to the, so the power of 1/6 to the 1/3, you can simplify the exponents to 1/2. So it's 3 over 6, that's 1/2. And then plus 3 times x to the power of 2 over 6, that's 1/3. And then the last one, there's nothing to simplify, so it's just 6x to the 1/6 plus 6 times ln in absolute value of x to the 1/6 minus 1 plus c. So there you have your final answer. Feel free to leave it here. This is pretty good answer, or you can change them back to radicals if you would like. Now, this was a bit challenging problem. There are a lot of concepts that you needed to borrow from your previous courses, so make sure to review them. I'll leave all the link in the description box that I think would be helpful for you.